Thank you, Alexander, for inviting us. Thank you for organizing everything. Um, for me, the Renew School program is one of the fascinating exchange all over Europe because you really can see how different situation you can have in renovating with prefabricated elements. I will start much more by project work. I'm an architect. I'm doing retrofit buildings since more than 10 years. We started in 2003, 2004 with the first prefabricated elements in housing situations, and the first building with in school building we did in 2008. We not only an architecture office, we are also doing energy concepts. So overall thinking is for us more than important. You can see where we are situated. I would like to show you mainly two front runner projects, one in Neumarkt in Styria, one in St. Gerhard in Carinthia. You can see that we are in the Eastern Alps, southern Eastern Alps, on the border to Slovenia and Italy. You can see also the population and temperature situation. You can see how the local situation is in Neumarkt and in St. Leonhard. These are very small villages. These are not very big cities. You can also see the sunlight, over the maximum hours of sunlight in winter. In both situations, it's very only 3 or 4 hours of possible sunlight in the winter situation. So we have a very cold climate. So basically, as you can see, I would like to compare the situation in Austria. We had in the late 1980s the first school renovations. As you can see on the left picture, there is 5 or 6 centimeters or VPS on the facade. That's where we started with renovation. And the right hand side, you can see Neumarkt, a concrete structure filled up with bricks in the 1970s. Typical building situation, building stuff in Austria. First, we start with Neumarkt. As I said, it's on the countryside. Also here, the building stuff consists out of very different typologies. Basically, we are looking on the concrete structure filled up with bricks, because this is the point where we started with renewing and basically first analyzing. That's what I want to mention first is, please, before you start with any concept, with any drawings, you have to analyze, you have to drill into the walls, you have to see what the structure is all about, especially about these old roof structures. They are really to analyze in detail, and you have also to analyze the way of use of the school building for the future, because, for example, in this case, we have the situation, the countryside is losing pupils, of course, so we have too much square meters, which we all have to heat up in the cold climate. So it's a big topic to reduce square meters in our school buildings. Of course, the local governments want to keep the square meters, don't want to reduce their building. The government want to reduce. So what we did, we did a concept how we can reduce the square meters and maybe improve the building stuff for the futures. So as you can see, this classroom in the middle of the building, you will remember this in a few seconds, because we can get rid of 4 classrooms in this area. So we have a huge new atrium for as meeting point, as an open school classroom, and a new situation for the whole school, for the whole area, for the whole village actually. Yes, so this divided in 4 sectors. This schools, maybe we look on C and D, and this is what we renewed with wooden elements. Basically, whole sector C is renewed with wooden elements. Sector D is a sporting hall. This is also to zero energy renovation, but we're in a conventional way. As you can see, we got a new entrance. We got a new atrium in this building, and we got a new elevator for pedestrians to have a new new space and a new way of coming into all levels. As you can see, one important thing is the detailing. The detailing before you start with building, you can see here is the existing level of the building. So only the construction we kept. You can see the yellow things are the existing points. The red line, the thin red line, is the airtight layer, the inside airtight layer, which is very important if you have a ventilation system, a HVAC system. And as you can see, there is the orange line. This is the very important line for the isolation, so that we don't have any thermal breaches in our detail. And of course, we have an air ventilation on the outside, on the suspended construction. And of course, we would like to have very nice details as an architect. So also this is all in this system details, which is very important to draw before you start with any searching for a contractor or anything in case of construction. So you can see our design, the existing building and the design. You can see this is a Western orientated open atrium with a glass wall. Here you can also see that we had on one hand a look on the daylight quality of the interior space. On the other hand, we have to make sure that we don't have overheating, because it's Western orientated. So we did a simulation of the inside space. You can see on option 0, if you don't have any outside shading, there is a level in Austria which tells you 26 degrees. The teacher can stop teaching. There is an Austrian law. So in this case, no shading in a typical summer week. Of course, there is no school in summer, but in May and June are the 2 critical months actually, and we have overheating, as you can see in the black-brown line. We also divided our analyze on the different layers between basement and second floor, but there was no different, as you hardly can see. This black line is actually divided in 4 different lines, but there is no different. Yeah. As you can see, option 1, there is a inside sunscreen. We simulated this. Of course, we can reduce a little bit the temperature, but of course we have to invest in the sunscreens. We have maintenance cost, all of this. They didn't want to have the inside sunscreen. We don't have any transparency. The option 2, an outside sunscreen, of course, would be the best. We are always underneath the 26-degree lines, but we have the problem also of maintaining and the investment costs and not so much transparency as we have now. So we decided to do airflow through the night, which is working like this. We open windows in the basement and on second floor. We are activating the existing walls of the inside space, and we open from midnight till 6 o'clock in the morning, and so we can reduce the heat in the way that we come hardly in the morning time over the 26 degrees. You can see if you go closer, we're coming over 26 degrees at 2 o'clock in the afternoon, but this is not a big problem, because at 2 o'clock in the afternoon there is not so much work in the school anymore, and we discussed with the teachers there, and they accepted to do option 3. So that's what we got in the end. Now, then we started with the construction. Actually, we did the construction in 2 summers. First summer we did the sporting hall and the connection area. Second year we did the classroom part of the school. So we had 2 times 10 weeks, and as Mark and Armin already said, we had also some preparation time in May and June. And this helped us to have no container classes, which are also costs for the government. Here you can see we have a pre-construction. We have the wooden elements as he is sitting there and bringing in these elements in position. The main thing is the connection of the new element of the OSB board to the existing plaster wall and the inside, because this gives you the airtightness. This is the main task if you work with this wooden element. You can see here on the right picture now how this work has to be done. These joints are the most critical things apart from the electrical installation. Of example, the sunshades, which is also a very critical part in case of airtightness. Here you can see the depth, how deep it is to the window, to the wooden windows. We gone for large, which is very local wood there. Of course, because we had this question before, this was a topic, the daylight, but we simulated also this daylight situation, and the teachers are very happy now with having a very steep board for the pupils to bring their presents on top. So and we have the daylight conditions really perfect. So it's very helpful. Here you can see the holes for the cellulose. We have blown in there the cellulose on site where it was not possible because of the joints to do it in the workshop. Some parts, of course, always has to be done on site. Here you can see the element before we mounted it. The worker next to it mounting it at time. Here you can see the steel plates, the consoles, which we needed to have it for structural reason. As mentioned before, the structural point in the construction is very tricky, especially in the existing situation. Therefore, you really have to analyze it perfectly and in detail with a good team. Otherwise, it's not. You can see how it looks like on site when the elements are mounted, and you can see the holes where we have blown in all the cellulose. Here you can see the winter paper. It's not like an airtight paper, because otherwise you have condensation in the construction. It has to be only the windproof. This is the reason that the insulation becomes higher quality and higher effect on the facade. Here you can see the daylight simulation, because this is the example. For example, on the left hand side you have south windows. Before we started with renovation, we had on the north facade exactly the same windows than on the south. Our energy concept was very hard to reach because the north windows were too huge in size. So we had to halve the north side windows. This we didn't want it to do without doing a daylight simulation, because we didn't want it to have the argues afterwards. We have less daylight in the sporting hall. So as you can see, we did it in very different versions. We have 7 or 8 versions of daylight simulation to show the client how the situation will be after renovation, and it's perfect. So we decided to make half of the size with the north side windows. Here you can see the sporting hall after renovation in the inside, and you can see on the left hand side the windows which have only the half the size than the windows on the south side, and you can see also the perfect daylight situation. Even if the sun is not shining, this is perfect. And you can see the ventilation system. This the ceiling, from the ceiling comes the air intake. On the wall, you can see the air going out. It's an overflow over the next room, next spaces, next rooms, and going central to a central ventilation and heat recovering system. Or I also prefer central systems because they are much more efficient, first, and second, they are much more spectacular and with higher quality for the air intake and for the ventilation system in the space, much easier to handle. Maybe a few of us will ask me why you have heaters on the ceiling. This sporting hall is also used for ballroom dancing and for social gatherings. And for this, we need heating if the ballroom is dancing is in the evening from 8 to midnight, for example. We need the heating from 6 to 8 before the people are coming for interior loads. We need to heating up a little bit. If we use the hall just for sporting, we don't have the heaters on. We had the heaters on in the first winter. It was actually too warm, so the housekeeping suggested to the head of the government to switch the heater up. Here the measurements from a typical January situation. The ppm, you know, the 1000 ppm CO2 level is the one we should reach. You can see we are we are perfectly actually. Here you can see the relevant humidity. I really suggest you not go underneath the 35 degrees in winter, in winter. Because otherwise the pupils and the teacher will argue about a dry throat. So it's very important to have this 35% of humidity, even if the CO2 level may be rising up till 1500 ppm. It's much less problem. You can see the temperature. We are of course around 0 or underneath in Austria in January, and you can see we are going between 22 and 24 degrees in the inside temperature. Here you can see on the next slide our heating demand. These measuring data we have, and you can see that the heating demand is 13.1 kilowatts a square meter and year. You all know that the passive house is on 15 kilowatt hours per square meter and year. So we have a real passive house renovation with wooden elements, in this case also measured renovation, which is quite important. And on the right side, you see, because this is often a question, how much electricity demand do we have for the ventilation system? And we have 4.9 kilowatts per hour and square meter anno, the electricity demand for the ventilation system. So this is really nothing. All in all, we need per year 13,000 kilowatts for the whole ventilation system of the classrooms. These are 13 classrooms, so it's really a huge actually building, and we have not a lot of demand. So here the finished project, as it is running there now since 6 years. So we have really lots of impressions of these buildings, lots of informations, and lots of also informations we use for our new projects. We are doing around 2 school renovations like this per year. So we are really use this information of monitoring. So I can really suggest you monitoring is very important for your buildings. Here you can see the wooden facade. You can see the air intake in the middle and the air exhaust after heat recovering. On the right and left hand side, you can see here on the left hand side the entrance for the sporting hall, and you can see here underneath the ground there is preheating of the air intake. So we have the air intake up there, and we have preheating with earth heat of the air before it comes inside the classroom. So we have really natural energy used by this in this project. A few more pictures of the classroom block, and on the left hand side the sporting hall. Here you can see on the right hand side the air intake of the sporting hall and the air exhaust of the sporting hall. Here you can see the new entrance area. As I mentioned, the western orientated facade is glassed, and you can see the opening windows for the night cooling. You can see the entrance is pedestrianized and has a new roof. A few more pictures from the school courtyard. It's a very nice meeting place. On the left hand side there is a wooden cube as library integrated for the children, which is quite nice to use. Here the inside area. I'm very close to finish. I'm very close to finish. Last few pictures. Here you can see the glass facade from the inside and the elevator covered with wood. And you can see there on the right hand side, the floor was actually the existing floor, you can imagine. So exactly where the hole in the floor is were the old classrooms before, and these floors we got rid of and developed a new space and also a new acoustic system and a new lighting and daylight system. Here you can see the daylight use of the shading, here the entrance, here the pupil, how they use it, and here a few night pictures. I say thank you, and please the questions, and if you have further more questions, please feel free to contact me per email. Thank you so much.